Okay, so today we're going to talk about isotopes. When I look at isotopes, basically it's a good reflection of Miss McClung going through ups and downs of her weight. I am still me, Miss McClung, but I'm looking at different things. I'm looking at my different mass. So when we look at the definition, it says atoms of the same element, so like Miss McClung, that have the same atomic number. Remember, that's the DNA, but also have different masses. So that means ups and downs in your weight. Okay? So remember, in identifying isotopes, it's the number of protons do stay the same. And also, the number of neutrons will change. So remember, the neutrons are neutral charge. All they care about is mass, their weight. Okay? Now, here we have how isotopes can be written. We start, first of all, with oxygen. Oxygen that we know has, when we look on the periodic table, oxygen has 8 protons. And in this instance, it has oxygen -16. That means that is the total of the protons and neutrons. So its protons are 8. Its neutrons are 8. So remember, subtract your protons from your mass number. Here is another situation where we have oxygen, but now its mass is 17. Now remember, protons stay the same, so they're going to be 8. So now you take 17 minus 8, and then you get 9 for your number of neutrons. And then the last one, 18, your protons are still 8, so your neutrons would then be 10. So you can see here's oxygen getting fatter. So when we look at this, why is decimal number or why is mass number a decimal? The mass number is that average. So remember, we got different isotopes. For instance, chlorine, mercury, arsenic, or americium that we have listed up there. All 4 of those elements basically can go through highs and lows on their weight. So what they do is they get an average of all the possible situations, and that's where we get that number. So the isotope that's closest to the mass number is the one that's actually listed in there, or the most abundant. Ions are charged, charged particle. So when we look at this, they can be positive or negatively charged. And remember, the charged particle that it is identified to are electrons. Electrons are located in the outer shell. Remember, shells, levels, orbitals. So those electrons could either be lost or gained. If you lose electrons, you are positively charged. If you gain them, I'm gaining those negatives, I'm gaining those electrons, then it is negatively charged. Your protons stay the same inside, so really you're just either losing or gaining those electrons. All right, and I hope you enjoy it. Today we're going to do a lab on isotopes.